Welcome to CCMAS lecture on TCE 402, Chemical Reaction Engineering 1. Lesson 1, it's on rate of reaction. My name is Jackson Akpa, and today is the 16th of July 2023. As an introduction, chemical reaction engineering is a field that studies the rate and mechanism of chemical reactions and the design of reactors in which they take place. From that definition, we see that there are two parts: the study of the rates and the mechanisms, and the design of the reactors. Today's class, we are going to look at the first part, which is on the rate and mechanisms of the chemical reaction. We'll start with the rate of reaction. The rate of reaction is the rate at which a species loses its chemical identity per unit volume. It can also be defined as the speed at which reactants are converted to products or the products formed from the reactants in a chemical reaction. The rate of reaction can also be expressed as the rate of disappearance of the reactants or the rate of formation of the products. A graph of this definition is shown, and we can see that the reactants start at a high concentration and they gradually reduce as time goes on inside the reactor, while the products start at zero, and as the reaction proceeds, they increase as they are being produced. Let's look at the factors that affect the rate of reaction. There are two categories of the systems. We have the homogeneous systems, those are systems that have one phase, example, gaseous phase, liquid phase, or the solid phase. Factors that affect such reactions are temperature, pressure, and composition. In homogeneous systems where you have more than one phase, you can have the liquid and the gaseous phase, the liquid and the solid phase, or even the three phases together, liquid, solid, and gas phase. Factors that affect the rate of reactions include, in addition to the factors that affect homogeneous systems, you have rate of mass transfer and the rate of heat transfer. Finally, let us look at some definition of the rate. From the definition, the rate should be in terms of a reaction component, meaning in the reaction, there can be one component, there can be two, there can be three reactants and products. The definition should be in terms of any of the reaction components. So we have 5 definitions here. We have a definition based on unit volume of the reacting fluid. You can see there RI, meaning rate of reaction of component I, which is a function of the volume of the fluid and the time. We also have that based on the unit mass of solid in a fluid solid system, which is shown there. You can see 1 over W, W meaning signifying the mass of the solid. Similarly, we can have that based on unit interfacial surface in a two fluid system, or based on unit surface of the solid in a gas solid system. For that one, we have 1 over S showing the surface area, while the D based on unit volume of solid in a gas solid system, you have RII equals to 1 over VS, VS standing for the volume of the solid. Finally, you have the definition based on unit volume of the reactor. However, this is for cases where the volume of the reactor is different from the volume of the feed. In most homogeneous systems, the volume of the reactor is equal to the volume of the feed, and the first definition holds. However, when that is not holding, then this definition holds, where R subscript V subscript R stands for the volume of the reactor. With this definition, we have come to the end of this short intro to the topic rate of reaction. Thank you very much.